Hey everyone, welcome back to Bug no Jutsu. In today's video, we're solving an interesting and intuitive LeetCode problem, Fruits into Baskets 2, which involves smart allocation and greedy thinking. Whether you're brushing up for coding interviews or just love cracking logic-based problems, this one's for you. So stick around till the end for some powerful insights and tips. You're given two arrays, fruits and baskets, both of length n. Each element in the fruits array represents the quantity of a specific fruit type. Each element in the baskets array represents the capacity of a single basket. Now, from left to right, you need to place each fruit type into the leftmost available basket that has enough capacity to hold it. Remember, each basket can hold only one type of fruit, and it can be used only once. If no suitable basket is found for a particular fruit type, that fruit remains unplaced. Your task is to count how many such fruit types remain unplaced after the entire process. Let's walk through an example. Suppose fruits equals 4, 2, 5. Baskets equals 3, 5, 4. Here's how the placement goes. First fruit type is 4. We look for the leftmost basket with capacity greater than or equal to 4. The first basket is 3, too small. The second basket is 5, perfect. So we place fruit 4 into basket 5 and mark that basket is used. Next, fruit 2. We start again from the left. First basket is 3, still available and has enough capacity. So we place fruit 2 into basket 3. Finally, fruit 5. We again scan from the left. First basket is used. Second is used. Third is 4, but 4 is less than 5, so this fruit cannot be placed. So in the end, one fruit type, the last one, remains unplaced. That's why the output is 1. The idea is to simulate the placement process using a greedy approach. We loop through each fruit type one by one, from left to right. For every fruit, we scan the basket array from left to right and find the first basket that hasn't been used yet and has a capacity greater than or equal to the fruit quantity. Once we find such a basket, we mark it as used, usually by setting its capacity to a special value like -1. This ensures it won't be reused for another fruit. If no such basket is found for a fruit, we simply mark it as unplaced. Finally, we return the count of all unplaced fruit types. Let's analyze the complexity. Time complexity. For each of the n fruits, we may look it up to n baskets. So the total time complexity is O, n square. Space complexity. We're modifying the input baskets array in place and using only a few extra variables. So, the space complexity is O, 1, constant. This problem is a classic greedy matching scenario. A few key insights. Always go left to right, both for fruits and basket search, because of the rules. The greedy placement ensures the earliest available basket is used, which reduces waste and gives later fruits a better chance. If optimization was needed in a large-scale setting, we could consider advanced data structures like multisets or trees for faster lookups, but for the given constraints, the simple approach is sufficient. Also, if the problem allowed baskets to be reused or multiple fruits in one basket, the entire logic would shift dramatically, so pay close attention to constraints. And that's it for this one. We explored a smart, greedy simulation to solve fruits into baskets 2, and learned how to approach such allocation problems. If you found this helpful, make sure to like, subscribe, and share it with your fellow coders. Let me know in the comments if you want an optimized version or a visualization of the placement process. I'd love to help out. Until next time. Keep debugging, keep solving, and stay sharp with Bug no Jutsu.